Okay, I think the recording is on. So hello guys, welcome to my first video. This video I am starting and because I want to learn something, and I want to learn something which is called communication, and I don't know how to communicate well. Uh, I The main problem is my English is not too good, and also I don't find words when I used to say any of the sentence. So yeah, let's just get started. So what we'll be doing it every day. We'll try to create a half-hour video, and yes, we'll try to create a half-hour video in which we will be trying to explain the thing which is there on my screen. Yep. So let's get started. Uh, okay. Yeah, let's get started. So yeah, what we'll doing today is we will be going through some genius guy PDF which is there on my screen. Uh, I am learning from his YouTube video which is called um, event driven architecture. Mainly I want going to learn Kafka, and Kafka is basically helpful for streaming, and also I am learning from this guy which is called Concept and Coding by Sriyansh. I have taken his membership, so this all the notes, all the credits, it all belongs to him. I am not here to teach anyone, but yes, I will be using his resources to record the video, and also I will think whether I will post this or not. So let's just get started. So yeah, today we will be learning about event driven architecture. So firstly we'll see what is event driven architecture. So yeah, consider it as a system design style where service do not call each other directly. Instead, service emits event and other service react to those events. So firstly, if we see this particular line, service do not call each other directly. What is service here? So if we know little bit about a service, suppose a website is hosted and front end is calling one backend. So backend, there is service in that service we call it as a backend. Why? Because there is only one platform and it's only interacting with that, and there is no other platform, there is no many multiple backend in which it is interacting. So yeah, like services here means services, multiple services do not call each other directly. So they don't call each other directly. Suppose okay, I'm my parents has two sons, and one, my name is service one, my brother name is service two. So what I'll do, I will not call him, and my mom is went out, so I will not call him directly that bro, my mom is out. uh, I will not do that. What I will do, service emits an event and other service react to those events. So what I will do, I will just write on paper, bro, mother is out, and I will just put it onto the table and I will go, I will do my work. You understood? So that is called event. So yeah, here a fact that something happened in the past, that is called event. So if we see here, immutable. So what is the properties of event? Properties are immutable. So immutable, what is immutable? Cannot be changed once created. Order created at 10:30 p.m. So suppose that chat I have sent for my brother, right? So it's suppose I have just written it down like um, I have created that mom went out, but now I cannot come back and change that chat and write something else. So it cannot be changed. Past tense describe what happened, not what to do. So it's like what happened, mom went to market. So it's not like what I want you to do, that will not happen in an event. It's like what happened in the past. So just like order created, what is order created? Suppose and someone I placed an order on Flipkart or Myntra. So what I will say, like just order got created, bro, not you have to place order. It's like something got created, so I'm just giving that info what happened in the past. Now what is like self-contained, has all info needed to understand it and contain. So the event should contain all the info which is needed to understand it. So like suppose mom went out, at what time she went out, what works why she went out, what works she have outside. So now we'll come here in REST distributed microservices. What happens? So what is REST distributed microservice? REST distributed microservice is something which is called where one service used to call other service um, directly rather than taking the help of any event. So if you will see here, a user came to website and he placed the order. Then what order service will do at that time? It will call the inventory service and it will check whether that the real-time inventory, that whether that particular uh, yeah, just a second. Yes, sorry. So yeah, it will place the order on the order service, and the API will come first, hit the order service, and service what it will do, it will just come and check in the inventory service that particular product inventory is available or not. If it is available, yes, then it will sends back the info to the order service that yes, order is available. You can proceed with the next further step. So suppose the order is mm, the sorry, inventory is available, then it will do the process payment and it will ask the payment service to do the payment. And suppose if the happy scenario, the payment is successful, so what it will do, it will come back and say the order service that yes, payment is successful. Now what it will do, it will come, order service will again go and say the inventory that yes, payment is done, now you can remove one of the inventory. So suppose there are 10 products, now it will be only 9 and it will say yes, it is done. Now it will send the notification, that yeah, your order is created, everything happened. Now it will do everything, and after that it will say order is placed. Okay. So now we can see that uh, ability, all service must be available at the same time. What is the problem with here? So if suppose one of the services went down, what will happen? If you see, suppose payment service down, no, we will not able to proceed with order creation. We cannot do it after also, we don't have any COD also. Suppose inventory service is down, we cannot place order. Like even no notification service, suppose I don't want to inform the end user that your order got successful, so even the notification service will be down, you will not able to place the order because everything is being connected one after another. So what to do? What else we have? Latency accumulation total, like it's, you can see now that latency is very slow. We have to ask order service, then order service to inventory service, but then payment service, then everything is like taking too much time. Then tight coupling is there, everything is like it's like holding like any like this very hardly. And scaling issue, you cannot scale one of them. Suppose if you scale this also, and if you have not scaled the payment service, what will happen? It will take almost same time, right? Because once it is working very fast, but it's depend upon the others order service. So it doesn't matter if you scale one of the service, you have to scale all the services here, so that your system will be very fast. So what we came with, we came with something called event driven architecture. what is event driven architecture? We understood it communicate with each other using event. Now it's like a same thing. We have another example where everything is same except there is one thing called event router. What is event router? It's a router you can say, like it help you to create the event, everything. This is the one who is responsible for creating the event and receiving the event, everything. So what, now if you will see here, we have placed order, and now same thing, we have placed order, and in the real time we have checked inventory. Why real time we need to check? Because if you not check in real time, then suppose inventory is already completed now, and if you check it after half an hour, then it make no sense, correct? So what we need to do, so we will come down and we will check, okay, it is inventory is there or not for that particular order. If it is there, we will put yes, let's put order as a pending status. And now the first thing, the order service will publish an event called order created. Where it will do, it will say to event router that yes bro, order is being created, now you can start your work. Now if you will see here, the first communication happened that order is being accepted. If you will see here, just what it have done, it have just checked the inventory if it is there or not, and once order is created, we have said the user that order is created, so that user will be happy to know that, and they don't have to waste that much time that whether my order is being created or not. Now what will it will do, once the order created happen, there is a async and parallel processing. So parallelly and async, what will happen, this event router at a time it will do two things. It will say push the order event and push the order create event, where to payment as well as inventory service. It will process the order and it will reserve the inventory. If it is successful, it will successful. Suppose there is a happy scenario not happened, then what happen, again event source will say no, now you have to again whatever that you have reserved the memory, just remove it. But if you see everything is happy in scenario, it's like it came here, it said yes, payment service completed, now you can just place the order, place the process the payment. Now if you will come here in the inventory service, it will push the order created event, and both of them happen in the parallel manner. It don't have to wait for one another. Now suppose we remove parallel processing, and now what we'll do, it will go come here, and also at the same time it will say that order is accepted, and the notification service is also said yeah, go and send the email, then we can say order is completed. Now what happened, if you will see here, advantage of event driven architecture, it is loose coupled, there is no direct dependency on each other, you can scale one and another, there is no dependency that one system only should be scaled up. Better resilience, temporary should not break the whole system. Suppose one of them down is like, there will be everything will be stored inside the event router, and we can reprocess the old event. Suppose if one of the services is down and again it came up, so again we will replay these things, correct? So far from our understanding, the key event driven architecture components are producer, event driven, and consumer. So if you see here, this was the producer, this is the event router, and this is the consumers. Understood? Okay. Now if you come here, how do event move through EDA? So we have a producer. What it do? It is publishing a message from producer to broker. So it's publishing, and what broker is doing? It is immediately pushing the message from the broker to consumer, and consumer must handle whatever rate broker is sending. So suppose I said order created, broker taken and just pushed it immediately, and you have to solve it immediately. That sorry, you have to handle that message immediately. Whatever you payment, if it is there, you have to do the payment immediately. You can't have to wait. So consumer can get overwhelmed. Like if too many messages come immediately, like, then what you will do? Then we have another we call pull. It is publish message. Message is stored in this. Whenever consumer is free, it will like give me one message. It will take the message, process at one place, then again give me more message. So this is called pull method. And the most famous, if you will see, it is called publisher subscriber versus streaming model. So event are published to active consumer. So whatever the active consumer means, like suppose whoever want to consume the event actively, you can say. So event are published to active consumer and then forgotten, that I have published and then forgot. If new is consumers join say tomorrow, it won't get yesterday message. Fair enough, nothing to explain in this. When it is used, we care about just delivery. Like just we will like, okay, I have put the message. We don't have any history and all. So it's like what example of this RabbitMQ exchange. So RabbitMQ is also one of the you can say asynchronous communication broker which help you to communicate. Now, but we have like we can't replay the history, correct? Once we publish, we published. But if you will come here for streaming, if events are appended in logs and forever on retention based. So it's like suppose I like order created, I have added in log. Then order payment successful, I have added in log. So everything is there in the log forever, and you can retain whenever you want. So when it is used, when you want to replay, and we want multiple consumer. Okay. If new consumer joins say tomorrow, it can read latest offset or it can read from day one if retention allows. So it's like suppose I said I wanted tomorrow yesterday message. So if in that configuration it is enabled that yes, you can just go to path and fetch those messages, you can do it. And the best example is Kafka. This recording whatever I'm doing, it's mainly on Kafka itself. So what are the challenge? We saw many challenges in REST API communication, right? But what is the challenge we are facing in EDA, which is event driven architecture? So as the event are processed in async manner, as the event are processing async manner, get call and migrate in the still data, but subsequent might I didn't understood this, so we'll jump to next. I'll try to check this and come back. Duplicate event. Most event router guarantee at least delivery once, so duplicates are normal. Yeah. Ordering process event might reach in out of order. So suppose some message had to come first and second had to come second, but there is no ordering, it can come in any order. Schema revolution, if schema breaks, all consumer will crash. Okay, yeah. So suppose I want something in like ABC manner, and I'm supposed receiving CBA manner, so everything will crash, all the consumer will go down. Debugging is complex, we don't know, and one bad message can even block the router. Now operation overhead, like must monitor for like what is the consumer flow, partition, queue, this all the things we will going to learn in future. where we have some use cases. This is not important, but yeah, let's see. One of the action must trigger multiple independent in. So suppose one event, if I want multiple consumers, so I can use event driven. Long running business, like suppose I want something 24 into 7, or it's working for 7 days, 8 days. So for that also, consistency, eventual consistency, and real time analytics, then we can use this. So yeah, that's what for today. I know it was not good, but yeah, tomorrow we'll be learning about Kafka, what is architecture and all. So yeah, it will be very interesting chapter tomorrow. So be ready for it. We'll try to complete this thing tomorrow. Okay. Okay guys, bye bye. First class done.